this video, we will discuss about shortest subarray to be removed to make array sorted. Given an integer array ARR, remove a subarray can be empty from array such that the remaining elements in array are non-decreasing. Return the length of the shortest subarray to remove. So what they are saying is that in the input we are given an integer array. We need to remove a smallest subarray from this array such that the remaining array is sorted in non-decreasing or increasing order, right? So what is a subarray? A subarray is nothing but a contiguous part of the array, right? So 3, 10, 4, this is a subarray. 2, 3, 5, this is a subarray. From this one till the end 5, this is also a subarray. This one is also a subarray. But 1, 3 and 4, this is not a subarray because a subarray is a contiguous part of the array. Now you need to find out the length of the shortest subarray which we should remove from this array such that the remaining is sorted in increasing order. So see, if I remove this much subarray, then what will happen is the remaining array will look like 1, 2, 3, 3, 5. And is the remaining array sorted in increasing order? Yes. So this can be one of the possible subarrays that I can remove. Its length is 3. So I will have to identify all such subarrays, and whichever is giving you the shortest length, that you need to return as your answer, right? So now how are we going to do this? So see, there are 3 possible cases. One is that this entire array is sorted in increasing order, right? In that case, you won't be removing any subarray, right? So in that case, your answer is going to be 0. Other possible case is that all of the elements are sorted in decreasing order, right? If all of the elements are sorted in decreasing order, in that case, what are you going to do? You are going to remove the subarray of length n minus 1, where n is the number of elements. Why? Because either you will keep the first element and you will remove the remaining elements, or you will keep the last element and you will remove all of these elements, right? So this is only going to happen when the entire array is sorted in decreasing order initially, right? So these are the 2 possible cases. Now the third case is that there is some subarray which lies somewhere in the middle of this array, and we need to find out such subarrays, right? So see, if let us suppose that this is the subarray that I want to remove, right? If this is the subarray that I want to remove, then in my remaining array, this will be a part and this will be a part, right? Can I denote these two as prefix and suffix? I'm just giving a name to them, that this part will be the prefix and this part will be the suffix, right? Now, so when you are removing this subarray, then this is the prefix 1, 2, 3 and suffix is 3, 5, and these two are sorted, right? So how can you identify a valid prefix and a valid suffix? So for a particular prefix and suffix to be valid, what conditions should be satisfied? That the prefix should be sorted in increasing order within itself, right? So prefix should be sorted, right? Whenever I am writing sorted, I will consider in increasing order only, right? Because eventually I want my array to be sorted in increasing order. That is the reason, right? And this suffix should in itself be sorted in increasing order, right? So suffix should also be sorted, right? What should be the third condition? So the third condition should be that the last element of prefix, which in this case is 3, should be less than or equals to the first element of suffix, which is 3. Because if that is the case, only then when I combine my prefix and suffix, they will give me a sorted array, right? If the last element of the prefix and the first element of the suffix, these are not satisfying the condition of less than or equals to, then when you will combine them, your array won't be sorted in increasing order. So here we are having 3. Let us suppose here instead of 3, we had 2. In that case, your 3 is not less than or equals to 2, right? So then that means this cannot be the valid prefix and suffix, right? So the third condition is that the last element of prefix should be less than or equals to first element of suffix, right? Does that make sense to you? Now you don't know that what should be the last element and what should be the first element, right? So what you can do is that you can try to find out all the possible combinations, right? So if I say that I am denoting prefix I am denoting prefix with ARR of 0 to left, right? So let me just quickly write down the indexes. So this will be 0, 1, 2, 3, 4, 5, 6, 7, right? So my prefix is always going to start from the 0th index and it will go up to some index which I don't know initially, right? So prefix will always be 0 to left, right? And what will be the suffix? My suffix will be from some index right till the end, right? I don't know from which index my suffix is going to start. That is why I am denoting it with right, and it will go till the last element in my array, right? So this you can consider as n minus 1, right? So this will be my prefix and this will be my suffix. Now I want to find out all the possible valid combinations of this left and right such that these three conditions are satisfied. The prefix should be sorted, suffix should be sorted, and the last element of prefix, which is left, should be less than equals to first element of suffix, which is right? So in all the cases where ARR of left is less than or equals to ARR of right, and this prefix and suffix are sorted, that is one of the possible answers. So in that case, what will be the subarray that you will remove, or what will be the length of the subarray that you will remove? Can I say that it will be right minus left minus 1? This will be the length of the subarray that you will remove, right? So if you will try to find out all the possible combinations of this left and right which are valid, then for every combination you can find out the length, and out of all those lengths, whichever is the minimum, that you can return as your answer, right? So now how are we going to do this? So see, consider one thing. For this prefix, what all indexes can be valid left? So this can be 0, 1, 2, 3. Only this much part. This 4 cannot be a valid left. Why? Because when you are considering this as the left, then your prefix will be this much. Is this sorted in increasing order? No. After this 10, we are having a 4 here, which is smaller than 10, right? So then that means valid prefix can be till here only. Or we can say that the left index can either be 0, 1, 2 or 3. Only this much, not beyond it, right? And similarly, for the suffix, only this much part can be valid, meaning our right will always lie within this range. It can be either 2, either 3 or 5. It cannot be 4. Why? Because if in any case you will consider this as the right, then this array is not sorted, right? So then that means what will be the initial values of our left and right? Left we can keep at 0. So first we are considering that this is my prefix, right? Now for this left, you need to find out the corresponding right? So initially what will be your right? Your right will be 2 because you can start only from here. So now when your left is at this particular index, you need to find out the corresponding right. How you will find out the corresponding right? By identifying the first element in this particular suffix where 1 is less than or equals to that particular element, right? So when my left is here, this condition is sorted. My right is here, this condition is also sorted, and this we need to identify, right? So for this one, if you see in this range, which is the first element that is satisfying the condition of 1 less than or equals to that element? So that is 2, right? So then that means one of the possible subarrays to be removed will be this much, right? And in this case, your right would be at 5 and your left would be at 0. What would be the length? 5 minus 0 minus 1, which is 4. This is the length that has to be removed, right? Then you will try to identify for the next left. So next left will be this 2, right? Now again, this was our range. Now what is the first element which is satisfying the condition? This 2, right? Because here 2 is less than or equals to 2. Then that means this is one of the possible subarrays that can be removed, and the remaining array will be 1, 2, 2, 3, 5, right? So in this case, right would be at 5 and left would be at 1. So it would be 5 minus 1, which is 3, and this is the subarray that we are removing, right? Then again, you will move to the next left index. So your left will come here. Now in this range, again, you will move your right towards the right to find out the element which is satisfying the condition of less than or equals to, right? So you will see this 2 is not satisfying the condition. So you will move your right to this 3. Then in this 3, it will satisfy the condition. 3 is less than or equals to 3. Then that means this is one of the possible subarrays that we can remove. So here we will do 6 minus 2 minus 1, which will be 3, right? Then you will consider this. Now for this 10, inside this you will see that you will go till the end. Your right will point to n in this case, right? Because all the elements are smaller than 10, right? So in that case, what you will do? You will do 8 minus 3 minus 1, which will give you 4, which is this subarray that we have removed, right? So this is how we are going to do. So as I said, what we will do is that initially we will keep our left as 0, right? And how are you going to identify the right? So right initially should point to the first element of the sorted range from the end, right? So initially we will keep the right as n minus 1, right? And now while our right is greater than 0, right? And our ARR of right is greater than or equals to ARR of right minus 1. Then that means this is making a sorted array. So in that case, you will keep on decrementing your right by 1, right? So at the end of this loop, your right would be pointing to the first element in the sorted range of the suffix, right? Now that you have got the initial values of your left and right, what we need to do is that for each left, we need to identify the corresponding right or the valid right index, right? So now, till when are you going to find out a valid right index for a particular left? While our prefix is in sorted range, while our prefix is sorted in increasing order, right? So what we will do is that while left is less than right, right? Because our left cannot go beyond right. Otherwise, our prefix and suffix will overlap, right? And that we don't have to do, right? So while left is less than right and and the previous element, which is left minus 1, should be less than or equals to the current element. Only in that case, we are going to check for this left. So initially left is 0. So for that, you won't be having a previous element. So in that case, you can put a condition here that left if it is 0, right, or this condition, right? So if left is 0, then also we will go inside. Otherwise, if left is not 0, then if the previous element is less than or equals to the current element, then also go inside, right? So now when you have gone inside, now what you need to do, you need to find out the valid right index, right? Now how you will identify that? So you need to identify the first index where ARR of left is less than or equals to ARR of right, right? Then that means while ARR of left is greater than ARR of right, you will keep on moving towards the right, right? So what we will do is we will run another loop here. Inside this, we will check that while our right is less than n, right? And ARR of left is greater than ARR of right? Till then, you will increment your right by 1. So whenever this condition becomes false, then it means either left is less than right or it is equals to right? So you will stop there itself. So your right will be denoting that first element where ARR of left is less than or equals to ARR of right? So in that case, if let us suppose we have created an answer variable, so we will update that answer to the minimum of answer comma right minus left minus 1, right? And we will keep on incrementing our left by 1 for this particular loop, right? So this is what we need to do. And at the end, we can return the answer, right? So now if we try to find out the answer for our two possible cases which we had discussed earlier, that if the entire array is sorted in increasing order or the entire array is sorted in decreasing order, right? So see, when the entire array is sorted in increasing order, so 1, 2, 3, 4, 5. in that case, what will happen is that, so initially left will be 0, right will be equals to the last element, and when you will come out of this loop, your right would be pointing to 0, right? Because here the condition is right greater than 0. So when the array is sorted in increasing order, your right will point to 0. So left is also 0, right is also 0. Will this condition satisfy? No, right? So in your answer, what should be your answer? 0 only, right? Because entire array is sorted, so we do not have to return any subarray. Now what will happen when the array is sorted in decreasing order? Then in that case, what is going to happen? Initially left will be 0, right will be equals to the last element, and when you will run this loop, then this condition won't satisfy, so it won't go inside this loop, right? So your left will be equals to the first element, which is 0, and right will be equals to the last element, which is n minus 1. Now in this case, when you will come here, this condition will satisfy. Left is 0, you will go inside, right is less than n, and ARR of left is greater than ARR of right, and you will do right plus plus. Now right will become equals to n, so you will come out of this loop, right? So now in this case, you will do right minus left minus 1, right? So right would be 8, left would be 0, and then you would do minus 1. So it will be 7, meaning 7 elements should be removed, either from the start or from the end, right? So initially, what can we keep the value of answer? We can keep the value of answer equals to right. Why equals to right? Because see, when the array is sorted in decreasing order, at that time we were going inside this loop. So through this line, our answer will be updated, right? When we are removing a middle subarray, in that case also your answer will keep on updating, right? But when the entire array is sorted in increasing order, in that case, you will not go inside this loop. And in that case, your answer should be equals to 0, right? And when this condition will happen, right will also be equals to 0, right? So you can keep the initial value of answer equals to right. Another thing that you can do is, since we are taking a minimum here, we can keep the initial value of answer as the maximum number, which is int max, right? Then in that case, before returning here, you will have to check that if answer is equals to the maximum number int max, then in that case return 0, otherwise return answer, right? But if you do this, then we can directly return answer, right? So let's quickly code it out. So first of all, we'll create a variable n which will store the size of the vector, right? Then we need to create two pointers. One will be left, which will be 0, and right will be n minus 1. Now we need to find out the first valid index of our suffix. So we will run a while loop. While right is greater than 0 and the current element is greater than or equals to the previous element, then in that case we will keep on decrementing our right? After this, we'll create an answer variable whose initial value will be right. Then we will run a loop for left. So it will be while left is less than right, and either left is equals to 0, right? Or the previous element, which is left minus 1, is less than or equals to the current element, right? Then that means this is one of the valid left. So we will try to find out the valid right for it. So we will do while right is less than n and ARR of left is greater than ARR of right. Then in that case, we will keep on incrementing our right by 1. And when we come out of this loop, we will update our answer to the minimum of answer, comma, right minus left minus 1, right? And we will increment our left by 1. At the end, we will return the answer. So let's quickly run this now. So our test cases are accepted. Let's submit this. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.